Okay, so today I'm going to take you through how to do two of these questions from today's assignment. Here I give you the ionic compound's name, and it could have a polyatomic ion in it. And then it's your job to figure out the formula, the correct formula, by balancing the charges on the metal and the non-metal. Excuse me. And then once you have the correct formula, you got to figure out the molar mass. So you're going to need a periodic table with you. You're going to need that list of polyatomic ions. So I'm going to do number 1 first. So here we go. Rhodium-2 chromate. So remember that the parentheses tell you that this is a variable charge metal. You don't have to, it sounds fancy, but it's just, it tells you what the charge is. So this rhodium, if you find it on the periodic table, it's going to be RH, I believe. Yep. So RH. And the 2 tells you that this has a +2 charge, okay? Chromate is a polyatomic ion. You got to pull out your list. Chromate, chromate, chromate. And when you find chromate, there it is. It says CrO4 with a 2- charge. So that's the first step you got to do, is figure out what the symbols are and what the charges are. This one I got from the periodic table. This one I got from my list of polyatomic ions. Now we got to do the game of balancing the charges. Well, notice that they're already 2+ and 2-. They balance out already. So you only need one rhodium to balance out one chromate. So now we just put it all together. It's going to be RHCrO4. All right. So that's how we do it. A single rhodium with a +2 charge will cancel out the chromate because that's got a -2 charge. So now we got to do the molar mass. All right, so I'm just going to do it this way. I'm just going to jump over here just to make it a little bit more obvious. So the molar mass of rhodium, if you find it in the periodic table, and rhodium is atomic number, I just had it, 45. So it's 102.91. So this is 102.91. Chromium, Cr, when you find that, it's atomic number 24, but the mass is 52. A nice even 52, actually. That's nice. And now we got 4 oxygens. And oxygen's easy. It's just 16. That one I just have memorized because there's so many oxygens in these things. All right, so now we just add up all the pieces. So we got to go 102.91 plus 52 plus 4 times 16, which is 64, but okay, whatever. And now it's calculator work. So my handy-dandy TI-84 says that 102.91 plus 52 plus 64, I get 218.91. 218.91, and that's grams per mole, because that's what molar mass is. All right, so that's how you do that one. Again, the first step is to get the charge of each individual ion. Then the next step is to balance it out correctly. In this case, they were already balanced, so that's how you're going to get the correct formula. And then the third step after that is to basically just do what I did here, add up all the pieces. All right, so let's do another one that might be a little bit harder than that. So now we're going to do number 4, manganese 3 nitrate. I picked this one because the charges won't automatically balance, so it's a little bit more interesting. So manganese is not magnesium, by the way. Manganese is Mn, and it tells it has a +3 charge. That's what it tells you right there. Right? You don't have to look it up. In fact, you can't look it up because it specifically tells you that this one's a 3, regardless of what its spot in the periodic table is. Nitrate, when you find it, it's NO3 with a -1 charge. Again, first step, you got to figure out what the symbols and the charges are before you can balance it out to get the formula. So now if you look at manganese has a +3 charge, and nitrate has a -1 charge, you're going to need 3 nitrates to balance out a single magnesium. So that's where the formula comes from. It's going to be Mn, and then you need 3 nitrates, so you got to use your parentheses, and it's going to look like that. So that's how you do the formula. Again, start with the charges of each individual ion, and then balance it out. Once you've balanced it out and you have the formula, we can do the molar mass. So I'm just going to rewrite this a little bit over here. So in this case, we have MnNO3, and you got 3 of those. So if you think about this logically, you have 1 Mn. If you have NO3 and then a 3 right there, that means you really have these things. Oops, these going on. You got 3 NO3s, right? That's what that means. That's what this 3 means. So you got 1 Mn. That means you really have 3 Ns and you really have 9 Os, right? If you just think about it logically, if you add up all the pieces here. So again, there's a lot of ways you could sort of organize your math, but this is the way I'm going to do it. The molar mass of manganese, if you find it on the periodic table, it's atomic number 25, so it's 54.94. So this is going to be, I'm going to erase this for a second. Okay. So this is, oopsies, that looks like a 2. This here is 54.94. Now we're going to add up the other pieces. We got 3 nitrogens. Again, we got 3 of those things. So 3, and the molar mass of nitrogen is 14.01. And then we actually have 9 oxygens. So this is how I'm choosing to write it this time. Again, there's a lot of ways you could write this whole thing right here. This is the way I'm choosing to do it. And now I just use calculator. So I'm going to go 54.95 plus 3 times 14.01, and I'm using parentheses on my calculator. You might not be able to see that, or you can't see that. There's no might about it. 9 times 16, and I get 240.98. 240.98 grams per mole. And that is how we do one that's a little bit more interesting.